Welcome back to College Algebra. Today we're going to be looking at section 5.5 called Zeros of Polynomial Functions. We're going to jump right in because we've got a lot to do today and it's a pretty heavy section. So let's get started. Given that it's a heavy section, our scripture for today is just a simple proverb, a little bit of wisdom before we start. Happy is the man who finds wisdom and the man who gains understanding. Proverbs 3:13. All right, let's get rolling. Okay, so last week we learned about synthetic division, and this week we're going to start picking up, or last video, we talked about synthetic division. This session we're going to pick up right where we left off, where they give us a value, and they want us to evaluate f of 3, negative 3. Now we could just plug and chug that negative 3, but the skill or the tool that we got last class is actually a little bit easier than plugging and chugging negative 3. So what we're allowed to do to evaluate that function at negative 3 is to take that negative 3 and synthetically divide it. And so first we're going to check and see 5, 4, 3, 2. It looks like we're missing the x1 term. So we need to be careful about synthetic dividing that. We're actually missing the plus 0x. And so when we synthetic divide, we need to write the coefficients of 2, negative 3, negative 9, 8, 0, and 2, that 0 being the missing one. And we're going to drop down our 2, and we're going to use the skills. If you remember from the last class, it was multiply and add. Multiply around back to that negative 3 and add going down. And so we have 2 times negative 3 is negative 6. Add those up, you get negative 9. Multiply to 27. 27 minus 9 is 18. 18 times negative 3 is negative 54. Add those up, you get negative 46. Negative 46, this is where you might have to go to a calculator. Negative 46 times negative 3 would be a positive 138. Add those up for 138. Multiply one last time for negative 414. And you get negative 412 as your remainder. So I said it was a little bit easier than plugging and chugging negative 3, but it still had some pretty hard numbers in it. But the cool thing about synthetic division that we just learned is that f of negative 3 is equal to the remainder. And so if you were to plug and chug negative 3 and be really careful with all of those powers, you'd get negative 412, which is pretty cool. So that's the remainder theorem, which just says that your remainder is the value f of k when you plug and chug your 0. So we're going to use this theorem that says that's how the synthetic division can help you find f of zeros or f of 1s or f of 2s or f of x's. And we're going to use that to actually factor unfactorable terms. And so here's what we're going to say. They gave us that x minus 2 is a factor, which means we know, this is a really important conclusion to get in your brain, that x equals 2 is a 0. And so what we're going to do is divide those things. We're going to take that 2 and synthetically divide it with our f of x. And checking again, 3, 2, 1, none. Remember there's an invisible 1 there. All right, so we can just write our coefficients of 1, 4, negative 4, and negative 16. And because they told us this is a factor, we know it's a 0. And because it's a 0, we know what we should get if we plug and chug it. If you plug and chug a number into a function and you get 0 back, then it's an x-intercept. And so that's what we're looking for. We're looking for this thing to turn into 0. So we drop the 1 down. And we say 1 times 2 is 2. Add these up, you get 6. 12, 8. 8 times 2 is 16. And 16 plus negative 16 is 0. Boom. That's a good thing. That means that that 2 was indeed an x-intercept. So if you see a 0 there in the remainder, that means that x equals 2 is a 0, which means that x minus 2 is a factor. Those two facts are the whole purpose of learning synthetic division in the first place. That's a really important thing for you to get. The reason we're synthetic dividing is to get that 0 so we can get that factor and that 0. And then we're going to backfill. Remember, we start with our constant, and then we backfill x, and if there's no plus, we add a plus. And we backfill x squared, and there's no plus, so we add a plus. And so we're going to rewrite our f of x using the factor we just found first. So the first thing we just found out was x minus 2 is a factor. But then that green factor in the top is our other factor. And hopefully that reduces nice and neat, and we can do it pretty quickly because we know that 8 has factors of 4 and 2. And if you add those up, you get 6. And so the next set of factors I'm going to write is x minus 2, x plus 4, and x plus 2. And this problem asked us to find the zeros, not the fully factored form, although that fully factored form is a great thing to know. And so x minus 2 gives us x equals 2, x equals negative 4, and x equals negative 2. And so what are our zeros for this thing? Well, there they are. And remember, if you want to write them as x-intercepts, that's probably a good idea to remember what you're actually finding this whole time. You're saying if I plug and chug any of those numbers in, I should get 0 as a result, which means if I synthetic divide any of those x numbers, we should get 0 as a remainder. And this is the premise of learning synthetic division, is so you can find zeros a little bit faster when you couldn't find them before. And so here we need one more tool to help us find these things. And this tool is a tool that takes the form of P over Q. Now, P over Q is not super descriptive. We're going to use it, but it's not the most helpful. And so sometimes I write constant over leading. Or you could even write last over first. And what we're looking for is those coefficients or constants that are last and first. And so what I'm going to say is I'm going to look right here and I'm going to say this is my last. This is my P. This goes on the top, this 1. And over here we have a 1. That's my Q. That goes on the bottom. And so what I have for P over Q is 1 over 1. And what I'm going to do, I'm not going to set it equal to anything. I'm going to factor the top and the bottom. And I'm going to say what times what equals 1? Well, you've got plus or minus 1 over plus or minus 1. And this is the set of all numbers, -1 and 1, that are possible rational zeros. These are all the possible rational zeros of this factorization. Right here's that phrase, possible rational zeros. The possible rational zeros are all the factors that you can make by dividing P over Q and factorizing both of them. And so what we're going to do is we're just going to synthetically divide 1 backwards L. And we're going to say our coefficients are 1, -5, 2, and 1. Drop it down, 1. So 1 times 1 is 1, -5 is -4, times 1 is -4 still, -2 if you add that together. -2 times 1 is -2, and we get a remainder of -1. And because that remainder is not 0, that means x equals 1, not a 0. And then we're going to do the same thing with -1. So -1, 1, -5, 2, 1, drop down it. You get a 1. And we're going to synthetic divide -1. 1 times -1 is -1. Add those together, you get -6. Multiply 6, add 8. Multiply -8, add -7. You have a remainder, and that means x equals -1, not a 0. And so what we just learned is that this f of x, or this function, has no rational zeros. It's got no zeros that take the form of a fraction, because those were the only two possible rational zeros. F of x has no rational zeros. That means it might have some crazy zeros like some square root 2's or some pi, 22 over 7's, but there's no, well, 22 over 7 is rational. There's no rational zeros that work in this function. So let's look at one that does have some rational zeros so we can see this p over q work the way it's supposed to. All right. So here we have a function. I'm going to start by labeling p and q. P divided by q. And so we're going to say 4 divided by 2. So p over q equals 4 over 2. And then we're going to factor. Remember, this is the important part, to get all the factors. And so we have plus or minus 1, plus or minus 2, and plus or minus 4 on the top. Those are all the numbers that can multiply to get you 4. And on the bottom, we have plus or minus 1, plus or minus 2. And so we're going to write a set of numbers using this fraction. And so watch this carefully. We're going to start with 1 over 1. 1 over 1 is just plus or minus 1. Then we're going to move to 2 over 1. 2 over 1 is just plus or minus 2. Then we're going to move to 4 over 1. 4 over 1 is just plus or minus 4. Then we're going to move to, so we finished all the 1's on the bottom. Now I'll change to colors here for a second and do the 2's on the bottom. 1 over 2 is going to give us plus or minus 1 over 2. 2 over 2 is going to give us plus or minus 1, which we've already accounted for here. And 4 over 2 is going to give us plus or minus 2, which we've already accounted for. And so this set of numbers is all of the rational zeros that are possible. That doesn't mean that they're all zeros. In fact, if we plug and chug a bunch of them, we're going to see they're not. But they're all the possible ones. And so where do you start? Well, we just start with the easiest ones for us to plug and chug. So I'm going to try -1 first. -1, and then we're going to use the coefficients 2, 5, -11, and 4. Drop down the 2. 2 times 1, or 2 times -1 is -2. Subtract, you get 3. Times -1 is -3. Add, you get -14. -14 times 1 is 14. Add, you get 18. Boom, 18. Not a 0. And so this whole box was kind of pointless. It didn't tell us anything. I mean, it did tell us that -1 is not a 0. But that's it. And so we need to try another number. We'll try 1 backwards. 2, 5, -11, and 4. Drop down the 2. Draw a line. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1 is 7. 7 plus a -11 is a -4. -4 times 1 is -4. And if you add those last two numbers, you get 0. This means that x equals 1 is a 0, which means that, I'm going to say this together a bunch because if you can just get these two things together, it's really important. So x equals 1 is a 0 is one of the facts. And the brother-sister fact of this thing is x minus 1 is a factor. Those two things are really important to work. They always work together, zeros and factors. Where do we get the zeros? From the factors. Specifically, setting the factors equal to 0. And then we're going to backfill. We're going to go in and we're going to say, there's our constant. We got an x. We don't need to add the plus because we already have a minus. There's our x squared term. We do need to add the plus. And so we've reduced f of x a little bit. We've said that f of x actually equals the first term, that red one up there, the x minus 1 term that just factored out, and then whatever's left over, 2x squared plus 7x minus 4. And then to get the 2x squared plus 7x minus 4, we're going to have to factor by grouping, which if you need to go back and watch a video on factoring by grouping, or if you just, I don't know, skipped through a couple of lessons, this is a really important skill to have. We can't just factor that straight up. We have to use grouping. So I'm going to split this 7x up into some terms that'll factorize nicely. So 2x squared, and I'm going to say 2 times 4 is 8. So probably something like positive 8x and negative 1x. And if you're like, whoa, where'd you get those numbers from? Remember, those are blue. Those are come from the 7x. If you're wondering, where'd you get those numbers from? Go watch the factoring by grouping section, or email your professor who'd be happy to work through factoring by grouping with you. And so f of x here equals x minus 1. And I'm going to factor out, looks like in the first two terms, probably a 2x. I think 2x will work. Let's factor out a green 2x, and what's left over is going to be x plus 4. And then from the second two terms, it looks like to get that x plus 4, I'm going to need to factor out a negative 1, so I'm left with x plus 4. And now one more factorization where I'm going to take the green and factor it, and the x plus 4s and factor them out, and I'm going to be left with f of x equals x minus 1, 2x minus 1, and x plus 4. And that came from, if I change colors one last time, factoring out the x plus 4 the same way we did, by dividing by x plus 4. And this was dividing by 2x, and this green one was dividing by negative 1. And so factoring by grouping came back to haunt us a little bit. So it's important to go back and practice that if you're a little shaky on how we got those factorizations. But this equation asked us to find the zeros, so we're one step away. We could say this 0 we're getting good at finding, hopefully, x equals 1. This 0 we're probably getting good at finding, x equals negative 4. This one we might still need to set equal to 0 and solve. And once we do that, we get x equals 1/2. So there's some zeros, and I'm going to write them as x-intercepts just so I remember what I'm doing in the first place. I'm finding x-intercepts this whole time. And I'll zoom out and pause for a second if you need to pause the video so you can see this whole thing. It's kind of a long problem. Something really interesting here. If you look back at the first f of x we ever had, there's no way to solve this other than p over q and possible rational zeros. We don't have another skill to solve this. We can't group enough times to solve this. We can't use the quadratic formula because it's not a quadratic, it has a cubed. We can't use completing the square because it's not a quadratic. We can't just set it equal to 0 and say it's 0 because there's a constant term. So really, this is the only strategy. If you look at that very original f of x up here, we don't have another way to do it. This is it. So I would encourage you to practice this because it's pretty tough. This takes some thinking as you're working through it and remembering what steps next. Just a cool side note while we're at it too. If you look at each of these terms, the 1, the 1/2, and the negative 4, they all do appear up here. See here you have a positive 1 and a negative 4 and a positive 1/2. All of those eventual things that we ended up with were in the possible rational zeros. Just a cool side note. All right. So along these lines, we say, well, what happens if you can't get down to the zeros because you have to use the quadratic formula at the end of the day and you get imaginary numbers? Well, we have this really cool theorem that says if you have one complex 0 or x-intercept, then you have to have 2. So if you want an example of this before doing the problem, here's an example. If x, or let's say if 4 plus I is a factor, ... so is the conjugate. So is 4 minus I. If you remember the complex conjugates from when we divided, there were complex conjugates when we divided complex numbers. We just have this rule that says if any zero is imaginary or a complex number and has an imaginary part, then so is its complex conjugate. Which I think is just pretty cool because it helps us solve a problem like this. It says, find a third degree polynomial with real coefficients that have 5 as a zero, negative 2i, and it doesn't give us the third one, even though it said third degree. And so how do we find that third one? Well, we say x equals negative 2i is a zero, and so is x equals positive 2i, the conjugate, where you flip the sign of the I term. And what that means is we have our three factors right away. Because if you remember, the 0 of 5 it means we have a factor of x minus 5. And so f of x equals, and I'm going to leave a blank here, I'm going to say x minus 5 times x minus 2i times x plus 2i to take care of both of those imaginary terms from this complex conjugate theorem. And what do you think goes in the blank? Because we've had it in every single example so far, in every single section, we've had an a value that we have to solve for. And so what we're going to do is we're going to go and take the one number they gave us. They told us that f of 1 equals 10, which means if you plug and chug 1, your output is 10. And we're going to use that and put it in for our x and our y. And so here we have 10 as our output and 1 as our 3 inputs. And everything else stays the same. And we just solve for a. It's going to take a couple steps to solve for a, but we're going to be able to do it. So 10 equals a times negative 4 times 1 minus 2i times 1 plus 2i. And so what I think I'm going to do here is FOIL these two terms first. First, outer, inner, last. Remember how you multiply binomials? And so 10 equals a times negative 4. The first term, 1 times 1 is 1. The outside term, positive 2i times 1. The inside term, negative 2i times 1. The last term, negative 4i squared. That was from FOIL. And if you remember back from we did imaginary numbers, I squared isn't I squared. I squared is actually negative 1. And so we have 10 equals a negative 4, 1. Ooh, those middle two terms cancel out because of a positive and a negative. Plus 4. So 10 equals a times negative 20. 5 times negative 4 is negative 20. And so a equals 10 over negative 20, which is just negative 1 over 2. And so our a value is just negative 1 over 2 the whole time. We just didn't know it. And so we have our f of x, which is equal to negative 1/2 times x minus 5 times x minus 2i times x plus 2i. But one more step, because the problem gave us a condition that it doesn't always give us, and it says with real coefficients, which means we actually don't want that imaginary number anywhere in our answer. And so what I'm going to do is I'm just going to FOIL and distribute this whole thing. So I've got negative 1/2 times x minus 5, and this is the exact same FOIL we did a second ago. If we need to combine these two terms, we're going to FOIL them the same way. So we're going to end up with x squared as the first term. The minus 2i and the plus 2i are going to go away. Minus 4i squared, which is the same thing as negative 1/2 x minus 5 x squared plus 4. And then I'm going to FOIL one more time right here. We're going to FOIL again. Sorry, I meant to write FOIL up here. And we get something like x times x squared is x to the third power. That's the first terms. Outside terms, we get plus 4x. Inside terms, we get negative 5x squared. And the last terms, we get minus 20. And then finally, my last step before we're done with this really long problem, was, make some room for us. We're going to distributive property out that 1/2 with a negative sign and get negative 1/2 x to the third power plus, well, minus because of the negative sign, 2x, because 4 over 2 is 2, minus 5 over 2 plus, because it's got negative times a negative is a positive, x squared plus 10. And that is f of x with real coefficients. I'll zoom out again. You'll notice as we get into this section, we're starting to get into a little bit more weedy problems. They're a little tougher to solve. So they're going to take some practice, and that's okay. I'd encourage you to practice on your homeworks. Really try to work through those homeworks without using Mathway or Photomath or any tool so that you know that you can do these problems. Because just watching me do them isn't that much help to you. Nobody learned to ride a bicycle by watching someone do it. So I'd encourage you to work through some of these problems on your own. All right. And lastly, we have a word problem, everybody's favorite. So this word problem says we've got a shipping container in the shape of a rectangular solid. So it's like a rectangular prism that looks kind of like this. And we needed to have a volume of 84. But we don't know exactly what all of the dimensions are going to be. They give us really specific conditions for the dimensions. They say the length of the container is 1 meter longer than the width. So length equals 1 meter longer than the width. Width plus 1. And then they say the height must be 1 meter greater than twice the width. So the height equals twice the width plus 1. And that leaves just the width to be the width. They don't tell us the width. And we know the formula for volume is length times width times height. And so if I plug those equations in, we get w plus 1 times 2w plus 1 times w. And we want to know what that w is. And so here we are. We have, if I take this 84 from the middle, and I take my all w term, we got 84 equals w plus 1 times 2w plus 1 times w. And in order to solve this thing the way that we need to, we are going to have to do some distributing. So I'm going to distribute that w first and get 84 equals w plus 1 times 2w squared plus w. I'm going to have to do the FOIL now, first, outer, inner, last. If you need practice with that, I would encourage you to go visit chapter 2. We did a lot of foiling. We're going to have to move a little faster now so you can get through the video. So 2w3, first term, outside term, w squared. Inside term, plus 2w squared. Last term, plus w. Combine like terms that are in the middle there. We get 84 equals 2w to the third power plus 3w squared plus w. So we're going to set that equal to 0 by moving the 84 over so that we can apply our principles from today. Plus w minus 84. And so what we're going to do is we're going to do p over q with this term, where there's our p and there's our q. And we're going to write out all of the p over q factors, which would be 84 over 2. And that's going to be a really long list of factors. So I'm going to put the plus or minus out front. I'm going to say, what are all the factors of 84? I've done them for you, but if you want to think through them, you can. You can pause the video and try to list them. But they're going to be 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. And the factors of 2 are a little easier. They're just 1 and 2. And so these are all the combinations of fractions of numbers that could be solutions. There's not. Based on it being a cubic, there's only 3. But these are all the ones that it could be that we know of. And so to save us a little bit of time, I'm going to let you know, I paused the video and I tried 1 and 2 and it didn't work. And so I'm going to move to 3 as an option to try. So I'm going to try this one, which is 3 over 1, letting you know I tried 1 synthetic division, didn't work. I tried 2 synthetic division, didn't work. So now I'm going to try 3. So 3 synthetically divided by our actual function right here. So we've got a 2, a 3, a 1, and a negative 84 as our coefficients. Drop down the 2, draw the line. 2 times 3 is 6, plus 3 is 9, times 3 is 27, plus 1 is 28, and 28 times 3 is 4, carry the 2, 84, and it's positive. And so look at that, we have a 0 as our remainder. Which means that one of the solutions to our equation was W equals 3. That means we could plug in 3 and get a solution for W. And now what we can do is use that solution for W to hunt down the length, the width, and the height. And so if we have 3 as our width, then I can use the blue equation to say the height is equal to 2 times 3 plus 1, which means the height is equal to 7. And I can use that red equation to say the length is equal to the width plus 1, which the width was 3 plus 1, and so the length equals 4. And so I've got my length and width and height all right there. Thank you for watching. I know this was a lot of work and we did a lot of math today. I'd encourage you to pause it, go back and watch these videos. It's really important that you master these materials and how synthetic division can apply to finding zeros so that you can factor things that were once not factorable. I'll see you next time. Thanks for watching.